We're on alternate segment theorem, and it states that if a triangle is inscribed in a circle such that the tangent line passes through one of the vertices of the triangle, then the angle made by the chord and the tangent line is congruent to the opposite interior angle of the triangle. So we are saying that, okay, let's just use a diagram. So this is the diagram. So if we have a circle such that a triangle is inscribed in that circle, as you can see, we have triangle ABC, such that one of the vertices of the triangle is the point of tangency. So the theorem, there must be a tangent line, there must be an inscribed triangle, it must be an inscribed triangle such that one of the vertices of that triangle is the point of tangency. So if you have anything like that, then this angle, as you can see, this theta 1 is equal to this theta 1. We can still call it chord tangent theorem, yes, because we have chords, two chords, CA and CB, with common endpoints. So this angle theta 1 is equal to this angle. Angle A is equal to angle CAB is equal to angle ECB. Also, the diagram here is also similar to what we have in the left hand side. So once we have an inscribed triangle, a tangent line, that the point of tangency is the same as one of the vertices of the triangle. So this angle theta 1 is equal to theta 1, while theta 2 is equal to theta 2. So that's what we are saying. So let's prove this theorem. So we want to prove that theta 1 is equal to theta 2, because see the inscribed triangle ABC and the tangent line DE, such that C is the point of tangency, which is also one of the vertices of the triangle. So let's add two auxiliary lines passing through the center of this circle. That's one will pass through the center, while the other will not. So let's call this A, B, C, D, E. So let's call this F. So what do you notice? Since the diameter is CF, which means that this angle must be 90, Thales theorem. And if you look at triangle CFB, we see that this angle here, look at the intercepted arc BC. So this angle must be theta 1, since this is theta 1 by Bowe's theorem. And to get this remaining angle here, is either we use triangle theorem, that's the sum is 180, or we use the relationship connecting the tangent line and the radius or diameter of a circle. Yes, from our basic geometry, if you have a circle and if you have a tangent line, the radius or the diameter is always perpendicular to it. So that's the two theorems we are going to use. So let's write what we've added. So we'll say that angle CFB is equal to, okay, we'll start with, okay, let's write, no problem. Angle CFB is theta 1 based on Bowe's theorem. So y angle FBC is 90 degrees based on Thales theorem. Therefore, angle FCB will either be 90 minus theta 1 based on angle sum theorem for triangle. That's the first condition. Is either 90 minus the remaining part of the remaining angle here is 90 minus theta 1 because it must sum to 180, or should be 90 minus theta 2 by reduced tangent relationship, what I stated down here. Reduced tangent relationship. So with that, since angle FCB is this, 90 minus theta 1 is also 90 minus theta, implies that 90 minus theta 1 is the same, is equal to 90 minus theta 2. Therefore, theta 1 is equal to theta 2. So we've proved that. So let's solve this equation under it. So they said find the value of x. So from the diagram, I'm seeing a tangent line and I'm seeing an inscribed triangle. So this is also x. So we are saying that angle ABD is x. Y, alternate segment theorem. So finally, we have a triangle with an interior angle x 124 and 20. Therefore, x will be 36 degrees based on angle sum theorem for triangle. The interior angle must sum to 180. So let's solve. Let's continue. We're asked to find angle RPS. Since this is A, I'm seeing a tangent line and I'm seeing an inscribed triangle. So this should be A also by alternate segment theorem. And also I'm seeing two parallel lines, ROX and UT. So this should be A by alternate angle theorem. So with that, we are asked to find angle RPS. RPX, which is this. So we now have a complete angle on a straight line. So let's solve. Let's just state. So first, we'll notice that angle PRS is A by alternate segment theorem. And angle RPO, that's this RPU, is also a alternate angle theorem. Therefore, the angle we are looking for, which is angle RPS, will now be 180 degrees minus 2A. Why? Angle on a straight line. So that's our answer. Option C. So let's look at this one. We're asked to find the measure of angle PQX. Without wasting time, let's add an auxiliary line running from Q to R. So I have this auxiliary line. Since I'm seeing a tangent line here, so this is 65 degrees based on alternate segment theorem. And also, this is 55. Yes, based on that same alternate angle theorem. So our answer is 120, option B. But let me now state so that it will be formal. So the first thing I discovered is that angle RQP is 65 degrees. Why? Alternate segment theorem. Also, angle QPR is 55 based on that same alternate segment theorem. Therefore, the angle we are looking for, which is angle PQX, is 65 plus 55, which is 120. So option B. We're asked to find the value of y. We should find the value of y. So as you can see, I have two circles. So since I have a tangent line here, this is 70 by alternate segment theorem. And also this is y. This is a tangent line AF. So this is also y by alternate segment theorem. So what do you notice? We have a triangle CAB, interior angle 50, 70, while we have exterior y plus 47. So the answer is now simple. The answer is 73. But let's solve formally. So I'm saying that angle CBA is 70, y alternate segment theorem so angle FAD is y, the same alternate segment theorem. Therefore, y plus 47, that's the exterior angle, is equal to the sum of 50 and 70, y exterior angle theorem. Therefore, if we solve for y, we have 73. So y is 73, option B. As to find the measure of angle SQR. So we are looking for SQ. So once we know this angle, we add it to 63. That's what we are looking for. But before we can get this one, we need this, because from alternate segment theorem, this is 42. So using an angle and a straight line, we'll get this. Finally, we'll add it to that. So from here, we see that angle UQS is 42 degrees. Y alternate segment theorem. Therefore, we see that angle TQX will now be 180 minus the sum of 63 and 42. Y angle on a straight line. So which is 180 minus, that's 180, this 180 minus 105, which is 75. Therefore, what we are looking for is angle SQR, which is 75 plus 63. The answer is 138. So option C. Asked to find what was the measure of theta. So look at theta, and I have 3 theta here. So first thing I noticed that I have a tangent line, so we need to use alternate segment theorem. But there is a little problem here. We don't have an inscribed triangle. Yes, because for you to use alternate segment theorem, you need a tangent line and also an inscribed triangle. such that one of the vertices of that triangle is the point of tangency. So we need to add an auxiliary line. So let's add. So I've added an auxiliary line. Let me call it this A. Okay, let's call it B, from C to B. So we have a complete triangle now, an inscribed triangle. So what do you have to say? You see that this is 3 theta, yes. Based on alternate segment theorem, this is 3 theta, this is also 3 theta. And as you can see, this is the center of the circle. Oh, so using inscribed angle theorem, which says that the central angle is 2 times the inscribed angle, so this should be 6 theta. So finally, we now have, okay, before the last step, this is the radius of the circle. As you can see, this is the radius, and we know that radius is always perpendicular to the tangent line, so this is 90. And finally, we now relate this remote interior angle 90 and theta with the exterior angle 6 theta using exterior angle theorem. So we are done with the solution. Let's just state the process. So the first thing I noticed is that angle CBA or O is 3 theta. Is 3 theta. Is that angle AO, that's the central angle. Angle AOC is 6 theta. Why? Inscribed angle theorem. As the central angle is 2 times the inscribed angle, and angle OCF is 90 degrees. Why? Radius tangent line relationship. So they're always perpendicular, always. So finally, we'll see that 6 theta is the same as 90 plus theta based on what? Exterior angle theorem. As the sum of remote interior angle equals exterior angle. So from here we see that 6 theta minus theta is 5 theta. So theta is 90 over 5, which is 18 degrees. So this is our answer, option B. So asked to find angle CDA. So let's label it angle CDA. So let's call it, that's it, that should be theta. And if you look at the angles given, we need to relate it to the one we are looking for. I'm seeing a tangent line and I'm seeing an inscribed triangle. So once you see an inscribed triangle and a tangent line, what comes to your mind? Alternate segment theorem. So this is 97 degrees. So, and I'm seeing, as you can see this line, AB is parallel to DC. So since they are parallel, DE acts, or DA acts as a transversal. So this should be theta by corresponding angle. So we are done. So we can finish up the solution. So we see that angle D, or angle CAD, is 97 degrees based on alternate segment theorem, and that angle BAE is theta based on corresponding angle theorem. Therefore, we can get the answer now. So if we sum, therefore theta will be 180 minus the sum of 97 and 29 based on angle on a straight line. So our answer should be 54. Yes, this is 126, so theta is 54. So it's a nice question. So we asked to find the measure of angle ABE. So let's call it ABE, let's call it theta. So we see that angle CBA is 90, yes, because I'm seeing the diameter of this circle. And angle CBF is 23/1/2 based on alternate segment. This is a tangent line and this is an inscribed triangle. So this angle and this angle are equal. So finally we can solve our equation. So we have that the first thing I noticed is that angle ABC is 90 degrees based on Thales theorem. And that angle CBF is 23/1/2 based on alternate segment theorem. Therefore, we see that theta will be 66.5. Yes. Because if you add this angle on a straight line, that's a straight line. FE is a straight line. So that's our answer, option B. So let's look at this. They said if angle BCD is 4 times CDF, then the measure of CDF is dash. Okay, so what I will do, I will call, let angle CDF be theta. So let's call it theta. Therefore, angle BCD will be 4 theta as given. So let's go to the diagram. So as you can see, I'm seeing a cyclic quadrilateral, and also I'm seeing an inscribed triangle and a tangent line. So from here we see that this angle should be 30 degrees, yes, by alternate segment theorem. So let's write it down before we go to another one. So that angle GDA is 30 degrees based on alternate segment theorem. So let's still go back to the diagram, and we called CDF to be theta. So let's call this theta. CDF is theta. And BCD, B CD will be 4 theta. So this is 4 theta as stated in the equation. So from this, since this is a straight line, GF is a straight line, once I get this, with that we can get theta. And how do you get this? You see an additional information. Are you seeing these parallel lines? AD is parallel to BC. And we know from our consecutive angle theorem, if you add angle ADC and angle DCB to be 180 degrees. So I was saying that this should be 180 minus 4 theta, because DC acts like a transversal. So this is a transversal. If you add this and this, it gives us 180 based on consecutive or allied angle theorem. So we see that angle ADC is 180 minus 4 theta based on consecutive angle theorem. So with that, what we are looking for, we can get it. We'll see that if you add, therefore if you add 30 degrees, 180 minus 4 theta and theta, it must be 180 degrees based on angle on a straight line. Therefore theta 180, 180, this minus 3 theta goes there, so theta is 30 degrees. So theta is 30. So see that theta, this minus 3 theta goes, so theta will be 10 degrees. That's 30 over 3. So our answer is option A. A very tricky question, but simple. Okay, let's move to the question. The next question. We are asked find the measures of D, E, and F respectively. So that is how I will solve this question, and it will be faster. So first of all, let's get the complete triangle, that's angle of the triangle. So this is 72, this is 34, which sums to 106. So the remaining angle will be 74 to make it 180. Yes. So that's 180. So finally we can relate, as you can see, we have this circle inscribed in the triangle, and we still have another triangle inscribed in the circle, and the big triangle inscribed another circle. So once you have anything like that, know that F, this F, that as if it's in the middle of 72 and 34, will be 72 plus 34 over 2. Yes, so which is 106 over 2. So our answer is 53. YD is the average of 72. As you can see, D is like in the middle of 74 and 72. 74 over 2, which is 146 over 2. So our answer is 73. And finally, E is in the middle of 74 and 34 over 2. So our answer is 108 over 2, which is 54. So these are the answers. So let me prove how I got this formula. So let's prove that. So assuming this is theta 1, theta 2 and theta 3, so we're going to use this theorem aside our alternate segment theorem. There's a theorem on basic geometry that if you have basic circle geometry, you have two tangent lines that have the same common point outside the circle, that the lengths are congruent. So I'm saying that this length, maybe if it's AB and we have AC, so we're saying that AB is equal to AC. So that's the first thing we have to know. So, and our using our alternate angle theory, alternate segment theory, we can solve. So let's solve. Let's go to the diagram. So as you can see, this length and this length are equal. So we have an isosceles triangle. Do you see it? So this angle and this angle must be the same thing. Yes. So what was it? We see that angle FEC and angle EFC will be 180 minus theta 2 over 2. Yes, based on isosceles triangle theorem. So the base angle are congruent or equal. And looking at this, you can still see that this angle, okay, let's use different ink. You can see that this angle and these are equal because this is an isosceles triangle. So what do you have to say? We see that angle ADF is the same as angle DAF. ADF and angle DFA will be 180 degrees minus theta 1 over 2. So therefore, we see that we have angle on a straight line, that F plus 180 minus theta 1 over 2 plus 180 minus theta 2 over 2 will always be 180. Yes. So this is F plus this is 90 minus theta 1 over 2 plus 90 minus theta 2 over 2 is equal to 180. So 90 plus 90 is 180. 180, 180 gone. Therefore, F will now be theta 1 over 2 plus theta 2 over 2, which is their average, theta 1 plus theta 2 over 2. So likewise, the same logic, we can apply it for D and E. So I used for F, since theta 1 is here, theta 2. So that same logic for E, theta 3 and theta 2 that's their average. So that's the theorem, the formula. That's the formula I use in solving the question. As PX and QS are tangent lines such that angle PSQ is 51 degrees. If R is a point on the minor arc PQ and angle RPS is 19 degrees, we're asked to find angle RQX. So what I will do, I have to draw a neat diagram first. So let's draw a neat diagram, a circle and tangent lines. Okay, we now have tangent line P x, because they told us pxq is 51. So tangent line QS and PX makes an angle that they intersected, which makes an angle 51 degrees. They said if R, let's call here Q, R's. So such that angle RPX is 19. So let me add auxiliary line RPS. So let's add it. So they said angle RPX is 19. So this is 19 degrees. And we're asked to find angle RQX. So let's add it. So let's call it R, that's this angle. Let's RQX. So let's call it theta. So to solve it, since I'm saying these points on the, I'm saying P, R, Q on the circumference of the circle. So what I will do, I will complete it so that I will have a triangle. So let's add an extra auxiliary line running from P to Q, so that we can use our alternate segment theorems. Yes, because I need to complete it so that we'll have a triangle. With that, we can solve the question. So what do you have to say? That this angle, remember, alternate segment theory is a tangent line, so this is also theta. And also from alternate segment theory, this is a tangent line, this is 19 degrees. So with that, we'll have a complete triangle, interior angle. So we are saying that angle, so we said let angle RQX be what? Theta, which implies that angle RPQ is equal to theta based on alternate segment theorem. Also, angle PQR is also 19 degrees based on that same alternate segment theorem. Therefore, if we sum 19 plus theta, that's this angle QP, plus angle Q, which is also 19 plus theta, plus 51, that's the 51 here, must give us 180 degrees based on angle sum theorem for triangle. Therefore, theta plus theta is 2 theta. 19 plus 19 is 38, plus that's 89. 180 minus 89 is 91. Therefore, theta is 91 over 2, which is 45.5. So our answer is option A. So it's a tricky question, but easy. Thank you.